What is up, people? How's it going? Back again with another project, and in this project I'm going to show you how to make a graph generator using Python's Kivy and kivyMD. Okay, so in my previous video I just demonstrated the project. Now I'm going to demonstrate it again, and then I'm going to make this project from scratch. Okay, so if I want to make a graph of x square, then let me type x square in Pythonic format, and the initial value is going to be, let's say, -10, and the final value that I'm going to test is +10, and the number of domain is, let's say, 100. Okay, here I got the graph. Okay, so I'm going to make this project from scratch. So guys, let's get started. Okay, so here I just created two files. One is main.py file, and one is layout.kb file. Okay, so I just splitted the layout.kb file to the right, and now I'm going to code on my main.py file alongside layout.kb file. Okay, so first of all, you have to install some let's say modules or frameworks. Okay, so I'm going to use Matplotlib, so you must install Matplotlib, and you have to use a garden called Matplotlib using Kivy garden. Okay, so open up your terminal or command prompt according to your distribution. So here I'm going to install Kivy garden. So for that, just hit pip install Kivy garden. Okay, now it is taking a bit of time. In my case I already installed it, so requirements are already satisfied. Okay, you can see, and let me resize my window. Okay, then I'm going to install the garden. The name of the garden that I'm going to use is Matplotlib. Okay, so garden install Matplotlib. So here we can see the package already installed in this location, and now you have to install Matplotlib. Okay, so for that, just simply hit pip install Matplotlib. Okay, in my case requirements are already satisfied. Okay, now I'm going to start coding on my main.python file. Okay, let me clear the window. Sorry, my bad. Here let me clear the window or terminal window, and I'm going to close this. Here first of all I want to import the Matplotlib library. Okay, import Matplotlib. Okay, now here I'm going to use Matplotlib from a different location. So matplotlib.use. So here I'm going to pass the Kivy Gardens location. Okay, so I'm going to copy a location or a link, and here I want to paste it. Okay, I'm using Matplotlib from Backend Kivy. That means the Matplotlib that I'm going to use is going to be from the Kivy garden. Okay, and then I want to install, or I want to import MD app from kivyMD. So from kivyMD.app import MD app. After that I want to import the screen manager. Okay, so from kivy.uix.screen manager. Okay, screen manager, import screen and screen manager. Sorry guys. And I want to load the builder module. So from kivy.lang import builder. And now I want to import. Okay, now I want to do the front end. The backend stuff we will do later. Okay, now I want to create a class called, let's say, home, and this class is going to inherit from screen manager. Okay, now I'm passing this class, and here I'm going to create another class called main, and I want to inherit this class from MD app. Okay, now I want to add the build function where the widgets and the functions are going to build. Okay, so here let me return okay, let me load my layout.kb file. Okay, builder.load file, layout.kb, and here I want to return my home class, and let me run my main class using this run method. Okay, now if I run this project, here we should get a blank window. Okay, so here we got a blank window right here. Now I'm going to add the front end stuffs like buttons, text box, and other stuffs related to my project. Okay, so here in my layout.kb file I want to call my home class. Okay, after that I want to set the name. No, sorry, here I want to call the class screen, and I want to set the name, let's say equation, because here I want to create the equation in this screen. Okay, then here I want to add a text field. Okay, so md text field rect. Okay, you can use whatever you want according to the kivyMD documentation, and let me add an id, let's say call function. So the abbreviation form of function is fn in my case. So let me set the size hint to the none and none. This is size into x and size into y. And here I want to set the width to 600, and the height is going to be 30 dp. And let me set the background color. Okay, background color is going to be, let's say app dot theme class dot bg normal. Okay, I'm just following the documentation. Okay, so don't get panic about it. Pose hint, here I'm going to set the position. Okay, so it is going to be center of the center of x is going to be, let's say 0.5, and the center of y is going to be, let's say 0.8. Okay, and hint text should be, let's say function of y. Hey, so in this text box I am just going to load the function, that means y equal f of x. Okay, so I'm going to save this, and let me check is there anything wrong? So here we got a text field. Okay, so and this is the hint text function of y. Okay, now I'm going to copy this piece of code and paste it here, here, and here, because I want to add 3 more text field. Okay, so I need to change the center of y. Okay, so I need to change the position. So the first position is correct, then I want to set second text field second text field's position. So it is going to be at 0.7, and then it is going to be at 0.6, and the final one should be at 0.5. Okay, now I need to change the hint text. Okay, so the last one is going to be the domain number of domain. Okay, so how many part is going to be the how many part is going to be actually from one value to another. Like if the first value is going to be 10 and the last value or the final value is 20, then how many part is going to be 10 to 11, or how many domain is going to be in 10 to 11. That means it is going to partition about it is going to make partitions about 100 times to changing a number. Okay, so here we are going to take the domain. Okay, so here, right here, we need to change this to, let's say, final value of x, and here it is going to be first value of x, or the initial value of x. Okay, and at the bottom we want to add a button. Okay, so you can use any kind of button. I'm using raised button. Okay, so I am calling the md raised button class. So md raised button, here it is going to be text, let's say generate the graph. Generate the graph. Okay, let me set the position pose hint. Okay, pose hint is going to be, let's say, center of x is going to be 0.5, and the center of y is going to be, let's say, 0.4. Okay, okay, now let me check. So there may be an error. Okay, I don't know, but pose in center of x is at 0.5, and the center of y, here I'm taking this as 0.4. I don't know. Okay, let me check another time. So here we got a spelling mistake. Okay, so it is going to be pose pose hint. Okay, now let me check, is there any error or not? So here we got a graph. Okay, so this is it. Number of domain, final value of x, first value of x, function of y, and I need to make another screen. So for that, let me add another screen class with this line. Okay, so here I am going to create another screen by calling the screen class, and the name is going to be graph because I want to add graph in this screen. Okay, and here I want to add a box layout, and the size hint y should be 0.9, and let me set the orientation. The orientation must be vertical. Okay, orientation vertical. Size into y is 0.9, and now I want to set the position. So the position is going to be, let's say, top. Okay, I'm going to set the position at the top. Okay, and on that screen, that means on the graph screen, I want to add a button. Okay, let me copy this piece of code and paste it here. The center of x 0.5, center of y is 0.4. But I need to change this position. Okay, so the position center of y should be at 0.1 and the center of x is correct. Okay, and the name of the button is going to be back to home. Now whenever the user is going to press this button, it is going to redirect to the equation screen. So on release root dot current equal equation. Okay, and whenever a user is going to press this button, that means generate the graph button, on release root dot current equal, let's say, graph. Okay, I hope everything is okay. Now let me check if is there any error in my buttons. Okay, here we got an error. So center of y at line 53, here I just did a spelling mistake. Okay, now let me rerun this. There was a syntax error. If I click the generate the graph button, here we redirected to the graph screen. Okay, so everything is okay. Now I'm going to add backend stuff. Okay, so for that I need to import the Kivy garden. Sorry, I need to import the Matplotlib garden. Okay, for that, from kivygarden.matplotlib dot backend kivy egg import figure. So if you are unfamiliar with this, just simply follow the documentation or examples of this garden. Go to the GitHub and find the garden, or you may check the description. Here you will find the gardens link. Okay, or the repositories link. Okay, now I'm going to import figure canvas, navigation tool bar to Kivy and figure canvas Kivy app. Okay, figure canvas Kivy egg. Okay, so let me explain here. Here navigation toolbar to Kivy is going to create a navigation where I can use some tools, okay, to zoom the graph or specify specify a point using the zoom button, or I can use the move button to hover over the graph. Okay, and the figure canvas Kivy egg is going to plot the graph to my Kivy screen. Okay, and figure canvas let me okay, now I want to import pipe I want to import a pipeplot module. Okay, so from matplotlib dot pipeplot sorry guys, my bad, import matplotlib dot pipeplot as plt, and now I want to create the canvas. Okay, so the canvas is going to be, let's say, before creating the canvas I need to set the figure and the axis. Okay, so I need to call the plt module or the pipeplot module. Oh, sorry guys, my bad, I just made a mistake, and here I am just imported the matplotlib.pyplot as plt, and then I want to create then I want to separate the figure and the axis by calling the subplot method, plt.subplots. Okay, now in my canvas I want to create the canvas using this fig variable or fig. So fig canvas equal fig dot, that means figure dot canvas. Okay, now I want to import numpy because I need to create, or I need to line space, or I need to make line space to my values. Okay, so I need to make some part, so for that I need to import numpy. I need some partition value from first value to final value, and that was called domain. So to create this domain I need to import numpy. Okay, so import numpy as np. So here in my home class I want to initialize my home class. Okay, so define init self, and here I want to pass the co-arguments, coargs super dot init, and let me pass the co arguments. Okay, now here I want to create a function called generate graph. Okay, now to generating the graph I need some values from this text box. Okay, now let me set an ID to this box layout. Let's say ID is box, and here let me change the ID of my first value of x. Okay, so it is going to be first value, it is going to be second, sorry guys, it is going to be final value. Okay, um, final value, and here it is going to be number parts, that means the domain numbers. Okay, number parts. Okay, now I'm going to load this ID to my function. Okay, to my generate graph function. Okay, so let's say self dot fn equal self dot ids dot fn, because I am loading this ID using this piece of code. Okay, again self dot first value of x equals self dot ids dot, I am loading this text. Okay, this dot first value, and here self dot final value of x equals self dot ids dot final value, and self dot number parts, that means the domain number. Okay, self dot ids dot number parts. Now I want to um, now I want to create partitions between the integers. Okay, let's say if the first value is going to be 10, then from 10 to 11 it is going to be 100 parts if the domain, that means number parts, is going to be 100. It is going to be 10 parts if the number parts is going to be 10. Okay, so I hope that makes sense. Now I'm going to load my, or I'm going to call my np module from I'm going to load np, that means I'm going to load numpy. So here before creating the line space, I need to convert this string. So these are all string, I need to convert this to integer. Okay, so first value equal int self dot first value of x dot text, and final value. Okay, final value equal int self dot final value of x dot text, After that I want to convert the number text, sorry guys, number parts equal int self dot number parts dot text. Okay, now everything is okay. Now let me set the line space by using the variable x equal np dot line space. So it is going to load the first value and the final value and the number of domain. Okay, number parts. Okay, so it is going to create the domain. Okay, so it is going to create the domain number from first value to final value. If the first value is 10 and the final value is 20, and if the number parts is 100, then it is going to make the 100 domain or the 100 numbers between first value and the final value. That means 10 to 20. Okay, and y equal, I'm going to evaluate the function. Okay, self dot fn dot text. Now so let me explain. This x is actually the domains, okay, and the y is the function. Okay, now I hope you got the idea. Now I want to plot using x and y. So plt dot plot x and y according to the matplotlib documentation, and I want to enable the grid. Okay, plt dot grid. Now I want to load this I want to load this graph, or I want to plot this graph in my Kivy window. Okay, so let me call the canvas. So canvas equal, I'm going to call the figure canvas, sorry it's my bad, I'm going to call the figure canvas Kivy egg. Okay, now here I'm going to call the GCF method, plt.gcf method, to create the plot in my Kivy screen. Okay, now I'm to load this box layout because I want to add the graph to this box layout. Okay, self dot ids dot box. Now I want to set the navigation. Okay, self dot nav equal self, sorry guys, here I want to load this navigation toolbar to Kivy class. And I want to load the canvas, or I want to pass the canvas argument to the navigation toolbar to Kivy. So this is going to create a toolbar. Okay, self.nav. Now I want to add the graph. So self.box.add widget self.nav.action bar self.box.add widget canvas. So it is going to first add the action bar in the top, at the top of the screen, and then it is going to add the canvas, that means the graph. Okay, so I hope everything is okay. Now let me save this file and check is there any error or not. So here we got a window, let's say x square or x to the power 4. First value, let's say -10. Final value is 10. Number of domain, let's say 100. Here we got nothing. Oh, sorry guys, I didn't bind the function to my generate the graph button. Okay, let me close this. Now whenever the user is going to press this button, generate the graph, it is going to call the graph function. Okay, generate grph, and I want to add a semicolon because it is going to run multiple function. So let me save this one and let me run this main.py file. Okay, let's say x square or x to the power 4 -10 to +10 and 1000. We got nothing. Sorry guys, we forgot the parenthesis. Let me rerun my file again. So we got an error, has no attribute line space. Okay, so I did a syntax error. There is a syntax error. Okay, line space, I need to remove the okay. Function of y -100 to +100. Sorry guys, here it is going to be the function. Okay, x square 1000 10,000. So here we got the graph and the navigation bar. Okay, so if I click the zoom button and let me zoom this area. Okay, so here we got the area, and if I click for the move button and if I drag, okay, here we can see the screen is moving. So I hope you got the idea how I created this application, and for much more details or explanation, just simply follow the documentation. So guys, that's for today's video. If you like this video, then subscribe my channel and press the bell icon. That's for today's video. Keep watching. Goodbye.